The dermis is between the epidermis and the hypodermis with two fiber types. Elastic fibers provide stretch, and recoil just means returning to the original length. This allows for flexibility. Collagen fibers are extremely strong and they resist stretch, but they will bend. So these limit the flexibility in the dermis, preventing damage to the dermis. So we have, as you recall, the upper layer of the dermis is the papillary layer, composed of areolar tissue, and this layer contains capillaries, lymphatic vessels, sensory neurons, and touch receptors. The deeper layer is the reticular layer, and this layer is dense, irregular connective tissue. Collagen fibers in this layer are going to blend with the upper papillary layer and the lower hypodermis layer for strength. And this reticular layer also contains blood vessels, nerve fibers, and the accessory organs. Here are reticular fibers of the dermis. The hypodermis, or subcutaneous, contains adipocytes. This separates the skin from the deeper structures and stabilizes the skin relative to the underlying structures. This is a site for storage of energy in the form of adipose tissue or fat. So we all know where we accumulate fat. In men, it's the neck, arms, lower back, and buttocks. In women, it's the breasts, buttocks, hips, and thighs. Both adult sexes have little fat on the back of the hands or the surface of the feet, and both adult sexes often accumulate fat in the abdominal region, a pot belly. This fat is often called visceral fat, and now we determine that a waist size greater than 35 inches for women and greater than 40 inches for men greatly increases the risk of chronic diseases such as diabetes and heart disease. So waist size is quite important. A larger waist size is a huge health risk. We'll be looking at sensory receptors in the epidermis and dermis. In the epidermis are free nerve endings. A free nerve ending would be the dendrite of a neuron. These free nerve endings are sensitive to touch and pressure. And tactile discs, or tactile corpuscles, detect texture and steady pressure in the epidermis. In the dermis, there will be the Meissner's corpuscles, or tactile corpuscles, that detect light, touch, pressure, and vibration. Pacinian or lamellar corpuscles detect deep pressure and vibration. And bulbous or Ruffini corpuscles are sensitive to stretch and pressure. The fibers of the skin, those elastic and collagen fibers, are arranged in a particular way. These lines are called tension or cleavage lines, and it's important for surgery. So surgeons will cut along those cleavage lines or parallel to those cleavage lines, and this allows for faster healing with less scarring. Cuts perpendicular to the cleavage line slow healing and result in more scarring. We're going to spend quite a bit of time talking about burns. Burns are from a variety of agents: heat, friction, radiation, chemicals, and damage to large areas of the skin will lead to death. It can lead to dehydration, electrolyte imbalance, which can then lead to damage to the kidneys and shock. So the severity of a burn will depend on the depth of penetration and the total area affected. So we'll be talking about both. So with depth of penetration, a first-degree burn is a partial thickness burn, and only the epidermis is affected. An example of this would be a sunburn where the skin is red, and this is called erythema. Another partial thickness burn is a second-degree burn, and the entire epidermis is affected as well as part of the dermis. Accessory structures are not affected. This is extremely painful. Blistering pain and swelling occur. Healing, you'll develop blisters. A severe sunburn may be a second-degree burn. Healing takes 1 to 2 weeks. And a full thickness burn includes the epidermis and dermis and possibly extends into the subcutaneous layer. These layers are destroyed. It's less painful than a second-degree burn. This cannot heal by itself, and grafting would be required. So skin functions affected by burns include fluid and electrolyte balance, thermal regulation, and protection from infection. The depth of the burn is evaluated with a pin. Sounds a little cruel, but if there is no reaction to a pinprick, it indicates a third-degree burn. And so the percentage of the skin that has been burned is estimated by the rule of nines. So in an adult, the head is considered to be 9% of the surface area. Each upper limb is 9%. The trunk is, the front is 36%. The back is 36%. Genitalia 1%, and each lower limb 18%. It's different for a child. So in terms of emergency treatment for burns, lost fluids and electrolytes have to be replaced. Repair requires, healing requires incredible nutrient demands. So not only for healing, but for maintaining thermal regulation requires high nutrient demands. The infection must be prevented by cleaning and covering the burn, and antibiotics would be given. The third-degree burn would require a skin graft, and that skin graft can be either a split-thickness graft, which is a transfer of the epidermis and part of the dermis, or a full-thickness graft, which is transfer of the epidermis and the full dermis. And the source of that graft could be your own skin, the patient's own skin. That's an autograft. That's the best choice. An allograft would be frozen skin from a cadaver. A cadaver is a dead person. Or a xenograft, a skin from an animal such as a pig. So a young patient with 80% of the body burned has a 50% chance of recovery given complete medical treatment. These days they're using cell culture to grow skin in the lab, so that's, the patient's own stem cells can be used to create the skin to cover the burn. We're going to talk about accessory structures of the skin. These structures originate in the epidermis during embryological development. Cords of epidermal tissue called epidermal columns grow into the dermis, and the hair follicles and the glands develop from these. Nails form from thickened epidermal cells in the dermis and form what is called a nail field. These are all located in the dermis but project through the epidermis to the surface. We'll be talking about the hair follicles, the sweat glands and sebaceous glands, and the nails. The hair follicles produce hairs that protect the skull and produce hairs to provide a delicate touch sensation. The exocrine glands produce sweat glands that assist in regulating the body temperature and excreting wastes, and sebaceous glands lubricate the epidermis. Nails protect and support the tips of fingers and toes. So hair is found everywhere on the body except palms of the hands, sides and soles of the feet, sides of fingers and toes, lips, and part of external genitalia. Each hair is produced by a hair follicle. Hair is composed of dead keratinized cells produced in that hair follicle. Hair is found almost everywhere. The follicle is composed of epithelial and connective tissue. The hair that is outside the skin is the hair shaft. The hair root anchors the hair into the skin, and the root hair plexus is sensory nerves at the base of the follicle. This is why we would feel the sensation of a single hair moving, or we feel that single hair being pulled out because of the hair root plexus. Each hair has an erector pili attached to it. This is a small muscle that will contract, pulling the hair erect. When it does so, secretions from the sebaceous gland ooze out of the hair follicle out onto the skin. That sebaceous gland is the oil gland, and the secretion is called sebum. Hair formation begins at the hair bulb. That's the enlarged portion of the hair follicle at the base of the hair follicle. The bulb surrounds what's called a hair peg. A hair papilla, which is just a peg or a column of connective tissue that has blood vessels and nerves. And surrounding that is the hair matrix, where the cells divide to form the hair. They're getting the nutrients from the hair papilla. The hair itself, the inner portion of the hair is the medulla, the middle portion the cortex, and the outer portion the cuticle. The keratin in the hair is both soft and hard, two different types of keratin. So the core has flexible, soft keratin. The middle layer, the cortex, has hard keratin, which gives the hair its stiffness, and the cuticle contains hard keratin. And you can see the cuticle in this picture is jagged or rough. Hair grows in a hair growth cycle. The active phase lasts 2 to 5 years. Hair grows at a rate of 1/3 of a millimeter per day. During the resting phase, the hair becomes detached from the follicle, and it's called a club hair. Once that follicle is reactivated, that club hair is shed, and variations in growth rate and duration of the cycle result in different lengths of uncut hair. Active phase, regression and transition. Resting phase, where the hair detaches, and then follicle reactivation and growth of replacement hair. There are 2 types of hair. The dark, coarse hair on the scalp or armpit is terminal hair. The delicate, shorter hair is vellus hair. The skin is quite important in forming vitamin D. The epidermal cells in the stratum spinosum and stratum basale convert a steroid compound into vitamin D. Without access to sunlight, you will not produce vitamin D. The vitamin diffuses across the basement membrane and into the capillaries. We also get vitamin D from fish, fish oils, and shellfish, and now food such as milk is fortified with vitamin D. The vitamin D that gets into the bloodstream goes to the liver, where it's converted to an intermediary product. The kidney will use that product to synthesize calcitriol. Calcitriol is important in the small intestines for the absorption of calcium and phosphate, and the bones use calcium phosphate for growth and maintenance. Without enough vitamin D, due to low vitamin D in the diet or not enough exposure to the sun, it means not enough calcium and phosphorus is absorbed in the diet, and therefore the bones will be soft. In a growing child, that causes rickets. The child continues to grow, the bones cannot support the weight of the child, and the bones become deformed. In adults, this causes a decrease in bone density and increase in fractures. The elderly are at a higher risk, with 75% decline in skin production of vitamin D. And here is a child with rickets.